Another draft physics presentation. Anyway, this should be a shortish video, maybe, hopefully. Sorry. It takes time to explain stuff. Anyway, so the Hilton guy is still badgering me. As people do, they just badger. They don't politely inquire or something. Anyway, so this is just a glass slides with a piece of diffraction film inside there, so you can see that. And the diffraction gradient is basically just lines. And that's all it is. Very close together. And the thing is, the more I played with it, I could actually create a pattern that showed the lines. You could actually sort of see the lines magnified, when you project it, because it diverges so much, it's magnifying the image. And you can actually see the hint of the little lines in the diffraction gradient, which I found very interesting. Alright, so I've also been thinking, the whole time I've been doing these experiments, about, there's supposed to be like a Brewster angle you can put this stuff at, and it's supposed to get 100% reflection from just a piece of glass. And, nowhere in the conversation is there every comment about that. So there is a point here in the glass, where I guess I can tilt this down. Okay, so that's just the glass. Now you can see those two. I wish this laser was a little less bright. Alright, so that's just reflecting of the glass, not on the film. So clearly two paths, and then the laser beam's going this way. And you can clearly see the two paths are pretty strong. Now that's just two pieces of glass. Now the more I project these, so when I tilt the glass, you can see how the beam that goes through doesn't get affected at all, but clearly the beam that doesn't go through is substantially changed in terms of its angle of reflection. Substantial change. Little tiny movement in the glass, big change in the movement of the reflection. Now this is the diffraction gradient. Alright, so you can see that similarly, depending on the angle, the spread changes quite a bit. So at certain angles, the angle, there's two angles. There's the angle of me shooting the beam through, and then there's the pitch of how I'm holding the laser to be able to get it to create the pattern. But you can see the pattern is the same, equal through both sides. And there's no mirror here. This is just a diffraction gradient. And you don't even need the half silvering if you have these layers. So the trick is, I guess I'll draw that part, that you have 6 surfaces essentially. The 4 glass surfaces and the 2 surfaces of the diffraction gradient. So I guess there's no point in me trying to explain some of the artifacts you see at a distance, but I'm just pointing out that, okay, just regular glass, you clearly get 2 beams, and yes, the one going straight through is bigger, especially in this variation. So it depends sort of on the angle, but sorry, I hit the thing. But there's still 2 substantial beams, no doubt about it. Just from glass, no mirror, just glass. You get 2 substantial beams, and likewise, there's both of these patterns are substantial patterns, and one of them's easily modified, by just slight changes in the pitch of the glass. And so I think that's interesting. Alright, so that's context for his comments. And so what I did see, as I was tempted to state, is that this whole refraction thing happens on every surface of the glass. So you have 2 pieces of glass, and you have the thin film, as it's called, in between, and you have to count each one of the surfaces. So there's 1, 2, 3, 4, 5, and 6. So, there's 6 surfaces. So light can reflect off the first surface, it can reflect off the second surface, it can reflect off the third surface, it can reflect off this fourth surface, it can reflect off the sixth surface, it can reflect off this sixth or seventh. I don't know how that ended up being 7 now, but whatever. Probably poor counting is involved. There's 6. And combinations. It can reflect all the way off the bottom, come back, reflect off this one, then come back and come out. So there's lots of modes for reflection. So, and each surface can be anything from 16% reflective to 0% reflective. So any one of the surfaces can have that reflective index, that higher range, that every 16% will reflect off this surface or 0 reflects off this surface. The tendency would be is that if this surface is 0, then this surface would be 0. That's sort of the rule. But clearly, from what I showed you, the amount of light that was getting reflected was substantial. So clearly more than 16%. So clearly there was a combination of 8 plus 8 plus 4 plus 4 plus whatever, 6 plus 6. It was clearly a substantial amount of reflection. And combinations thereof. So is that all I wanted to do? Yeah, so anyway, so the thing I did notice was so when I reflected just the 2 surfaces of glass that have an air in between them, so that still counts as a surface, ironically, the air. I was getting, in so you'd get the reflected beam, and the reflected beam was creating a tiny bit of the 2 slit pattern. It was like this kind of thing was happening. So you were without any diffraction gradient, so nothing in between but air. You were getting what the pattern was representing, I would argue, was the fact that there were these different refracting angles, that light was coming in, and it not only goes in and reflects off different surfaces, but it does so at different angles. The light reflects this angle, the refraction angle is different, and then it goes back, and then it refracts, and then it bends up, and then it comes up, and it refracts, and then it refracts. So the angle you get are, these various points are the different angles because of the fact that nothing goes through the medium without getting bent a little bit as it goes through the medium. The transitions, and especially the transitions from the thinner medium to the more solid medium, and that's where you have also a phase difference in the light. So anyway, I thought that was also interesting, that you were getting the makings of the doubles, the single slit experiment, and there technically isn't a slit, except for the difference in the refracting medium of the airspace between the 2 pieces of glass. So again, lots of ways to make one of these beam splitters, and clearly it really makes a big difference how you make it. And so another argument that I was making was that in the beam splitter, when the light that goes through the beam splitter is diffracted, even if you didn't count, let's say you let this light spread. Now you saw how much it spread for just 2 inches away. So I don't want to show it again, but I'll show it again. Just look at the tiny amount of distance. This laser is only 1 inch from the surface, and you have a huge amount of divergence. Look at it. It's a huge, for 1 inch away, the divergence in the beam, that is, if you count all those little spreads, And look what the brightest one isn't it in the middle. Isn't that curious? See, unfortunately, it doesn't show up as well because of it's too intense. You know, it's good and clear on my piece of paper here, which is just kind of disappointing. You know, that it's so clear on the paper. But the brightest spot on this side. So look at the brightest spot. It's not in the middle. You know what I'm saying? I mean, there's 4 little dots on one side and only 1 dot on the other side. That's frickin' curious as heck. Shouldn't be that way. You know, technically, the brightest one should be in the middle. Well, anyway, that's kind of strange, gotta say. See, if I go to a 90 degree, so now I'm shining the light right into the, and it's still reflecting. Look how much light's still coming back at that 90 degree angle to the glass. But now I get the right pattern on both sides. That is interesting. I'll have to figure out what that means. But I'm just saying, this is just glass. I mean, you know, with this stupid diffraction gradient in there. And look at all the action you have. Lots of divergence. Incredible amount of divergence. Circular divergence. That there's so much divergence. Okay. So the problem would be in designing an interferometer that if you're going to basically say, okay, I'm only going to count that middle dot. I'm not going to pay any attention to the little dots going this way. So let's say you do that. Well, then this is only you know, 80%, let's say, of the light goes to the center dot. I think it's a lot less than that. You can make your own judgment about how bright the 1 dot was. It's certainly brighter than the partner dots, but if you add up all the partner dots, you know, it looks more like 50%. But whatever, let's just say they're right and it's 80. This beam then will only be 80%, and I'd say it's less. Then the beam that goes this way comes back and then diverges at the last path. So the 2 beams aren't even going to be of equal intensity when they get done doing their 2 different paths. So if you use a 50-50 beam splitter and you're not paying attention to this light, you're just not even looking at it because it's spreading so much you can't even keep it in the experiment. It's shooting right out of the experiment. It's diverging so much. Then all you're getting is a portion of one path, and I'd say this is more like a lot less than 80%. Well, clearly it's less just because of the fact that both beams are 50% of what they started off as, and now it's 80% of 50%. So I'm just saying it's certainly less proportional to the other beam. So the other path is going to be much brighter than this path. So a 50-50 beam splitter would be giving you a 60-40 or a you know, 30-70 intensity difference, which, you know, seems an important. That big an intensity difference seems that something would be affecting the pattern you're going to get, you know, in terms of what you're watching or looking at as the consequence of the experiment. All right, now I'll read the comments in that context, and just 2 comments, so it shouldn't be too long. And such. Probably don't need all this light because it does ruin the you know, the cameras are not perfect at getting this exposure thing right. So move this down and go to the comments, which is this here. Alright, so I'll read his, I think this is the first comment first, but who knows. Okay, so you say at 1020 that the interesting thing about the diffraction gradient is that as you make the holes smaller and also add more holes, the center light actually gets smaller. Well, I didn't mean to imply it's by their mathematics it's supposed to get narrower. That is, so more intense and narrower. Now I haven't seen it do that. So frankly, I don't know if that's true. That's what they argue. Now, what I would say is that you could see the dots are clearly dots. Like the rings in the Newton's rings, there's rings. So clearly the divergence is limited to the center beam, but it's clearly diverging. So if you want to ask the question, I mean, I guess I could, it's not enough distance for me to show it, but if I shoot the thing against the wall, that pattern, the middle dot will definitely be bigger than the laser beam started. So if the laser beam started this big at 5 feet, the laser beam is going to be that big. So the center dot. So it's still diverging. It's still spreading out. Not nearly as much as all those little partner dots that really spread. Okay. Actually get smaller and the side beams go further apart. Yes. So you're losing the light that's spreading. The partner dots aren't even in the experiment anymore. They've diverged so much. And your center point is confined, but not as much as their math says. I don't think it comes anywhere close to being as focused as they claim. It just doesn't. I mean, I saw it. I did the experiment. Yes, that's the point. The middle beam gets smaller, as you say, and the side beams go further apart. Frankly, it's not the point. My point's exactly the opposite, that those side beams are Newton's rings, and without them, you don't have any rings. Okay. As you make the hole slits even smaller, then the side beams will go to the sides more and more until a threshold point where they won't even appear. I don't think they can be an infinite angle, so there's only an angle, and you can make them go further by changing how far away you are. So the further away you go, the harder it is to resolve the smaller angle, obviously. And that's when you're left with only the middle beam, which isn't diverged. Right, the middle beam, that's only 80% of the light, and it is still diverged. So again, I'll just point out that if I shoot it against a wall 3 feet away, the laser beam is a smaller beam. The beam that went into the glass is smaller than the beam projected. Alright, a beam splitter, unlike a diffraction gradient, is designed to have such significantly small holes for the purpose of having both beams be as equal as possible. Well, again, I just point out how that's not possible for both beams to be as equal as possible if one of them is diverging insane amounts and one isn't diverging anywhere near those insane amounts. It's just diverging as much as the laser light is diverging. Do you still want to claim that one beam is 3x or 5x larger? Yes. Duh. Or I'm going to claim that if you're not counting its largeness, it's 20 or 30 or 40% less bright, as you have done in the past. Yes. I'm saying you can't call it a 50-50 beam splitter if you're only collecting 20% of the light from one side and 50% from the other side. That's not 50-50. You haven't touched a single beam splitter in your life. Fuck you. I mean, really, just fuck you. Right? I mean, I point out how your theory is shit. How the arguments being made are shit. How Wikipedia pages never even show the beam splitter. They never even show what happens to light inside of them. They don't even talk about the fucking surfaces of the beam splitters, which have a reflective index. They don't even discuss any of the fucking optics, you fucking cunt. You theoretically have no founding for your assumptions that you put into the experiment. And you fucking lazy assholes just accept what they tell you. It's a 50-50 beam splitter, even though theoretically that's impossible because the surfaces alone break it. You piece of weaselly shit. In your life. Then you think these peripheral beams from the diffraction grating are comparable to the rings of the interferometer. Yeah, that's exactly what they are. If this stupid thing wasn't a diffraction gradient, that is, if it didn't have straight lines in it, then the pattern wouldn't be just 6 beams, 6 little dots. Those little dots you saw are because these have straight lines. If the little slits were broken in different ways, all going at different angles, then can you figure out, you little fucking retard, that the pattern would be going in all directions then? And those 6 little dots going out to the 2 sides would form rings, you stupid little fucking Weasley cunt. You arrogant prick. Fuck you. Figure out what a little bit of common courtesy is, shithead. If you're going to be this obnoxiously arrogant, then you have to be right. That's one of the rules of obnoxious arrogance, is you have to be right. You can't be completely fucking wrong. And you're fucking wrong, douche. Alright, so then he says, so I really am curious for a definitive statement. I mean, I have made definitive statements over and over, declarations pretty clear, that none of you assholes paid any attention to any of these details. You just make these fucking assumptions and then I demonstrate it. I first gave you the theory and now I've shown you the fucking theory. In working, actually happening, you dumb cunt. Are you saying that if I have an interferometer but without mirrors, again, the mirrors aren't going to fix the diffraction of the light, the divergence. So the mirrors, I don't know why I would have one without mirrors. It's kind of hard to make an interferometer without mirrors. I mean, call it an interferometer. The reflected beam will be undiverged. That's right. Not diverged as much. But the other beam will have rings around it, because it is diffracted. But the other beam will have rings around it because it is diffracted. No, it'll be spread out more. Let's see, is there some way I can do this? See, that's the problem with this experiment. So we'll go back to the experiment. Is because I can't really show you because of the surfaces. So theoretically, if you just put the silvering on one face of the glass, then you have an uneven interferometer, in the sense that one side reflects without going through glass, and then the other side has to reflect going through the glass. So, I don't, maybe I have to draw a picture of that. See, the problem is that you don't get what you would anticipate, that the side reflecting wouldn't, okay, be doing this. Alright? This is the reflective side here. Let me turn this over. And look, the reflective side is doing exactly what the not reflective side is doing. It's doing the same exact thing. It's creating the same exact pattern. And theoretically, it shouldn't be doing that. And the reason why it's doing that is because of this layer of glass. The light is going through the gradient and bouncing off of it and then bouncing to this side. So that's what's throwing this side off, is that it's not purely reflecting, it's going actually through the gradient, reflecting off the other glass surface, and then going back through the gradient again. It's going through it twice, essentially. So it doesn't get the pure reflection, which is interesting, right? I mean, it's kind of interesting that that's what's happening here. I can't make a single reflection. But that might be why the wrong dot is brighter, is because of that fact. But obviously both paths would be diverging a huge amount if this was the experiment. So if this was the beam splitter, clearly you can see both paths are fucked. You know, both paths are diverging almost like 180 degrees worth over just a couple of inches. It's already diverging tremendous amounts. And like I said, the more I just subtly change the pitch, and it's just, it doesn't get better, it just gets worse with distance. You can see that with distance it diverges an insane amount. And so both paths are doing that if you have two glass surfaces with the mirror in between, which I think is the way most beam splitters work, I think. And so then you have this whole problem of refraction. This is a refraction phenomenon. It's not beam splitting at all in that sense. All right. Yes. So in that sense, the beam splitter is, the two beams would be at least more equal in that they're both diverging an insane amount. And so both of them are not using most of the light. And they're only representing the light based on that dot, the middle dot. But then again, you still have the problem of this beam is going back through again. This middle dot, this little dot, goes back through the glass one more time and gets diverged. So even though they went equal this way, right, and they came out equal this way, even though technically they shouldn't have been equal, because this one went through and this one reflected, and they should make up that difference. Like one of them has one reflection, one of them has one going through. When this one comes back to reflect, I guess it's going to diverge again because of refraction in this surface of glass. So if it's only got mirroring on one surface, if it's a one surface, just the two surfaces, and it has the reflective surface on one surface, that won't work, because then you'll have the unevenness. So it really depends. You have to really analyze the beam splitter. Is it a thin film beam splitter? Does it have 6 layers? Does it have 2 layers? Does it have 4 layers? It's really important to understand what your expectation should be regarding what light gets through it. Alright, let's see. Alright, we'll finish up this comment and move on. Let's see. Are you saying that if the interferometer, but I don't know what the hell happened there. I didn't touch anything. I didn't do that. Are you saying that if I have an interferometer without mirrors and reflected beam will be undiverged, reflected beam, but the other beam will have rings around it because it is diffracted? The diffraction, let's understand, the divergence is one thing. The spreading is one concept. The fact that there's pattern to the spread is another concept. So diffraction is sort of a word for, in my opinion, the pattern, and divergence is the concept of the spread. So, just asking for clarification. Well, I don't know, I can't clarify it more than what I've just demonstrated. And the point is what we're told this thing is doing is different than what it's doing. Clearly it's refracting both beams, and there's a lot of reflecting going on between the surfaces that compose the beam splitter. And that's a significant fact when you think of the angles. As the angles change when the light's going through, those angular changes mean a different reflective angle. And so, again, I'm arguing that the interferometer is not measuring changes in wavelength. It's measuring changes in distance created by divergence. The straight line is shorter than this diverged line in getting anywhere. So the more the lines diverge, the longer that path is, the more out of phase those photons will be. Alright. Yeah, I don't know if this still don't know if I've proven enough here, but you should at least have a little caution in your assumptions and declarations about what's causing the effect, because it's a little more complicated than just saying it's a 50-50 beam splitter, because it's not. Alright, that's probably enough as a minimum statement, I think. But anyway, be as reckless as you want. I don't care. I mean, I'm just saying. That's the problem with physics. I'm just saying, it's all this reckless assumption. Too quick. Draw assumptions, draw presumptions about what is happening because it looks a little bit like something else, even though it's not the same thing. As I pointed out, with the pattern created by the interferometer, the rings aren't in the right proportion. They're not the same interference pattern you see in the single slit or the double slit. The proportions, the weight of the rings is wrong, and that's probably for a reason. Until next time.